Hello and welcome back to the class of 5G. In previous lecture, we talked about handoffs and how denser cellular network was not the go-to solution for 3G. We also promised that in this lecture, we will talk about a solution which did work out for 3G, and that is CDMA, also known as Code Division Multiple Access. So, what is it? Let's check it out. The best way to understand code division multiple access is to have another take on the same problem we had seen earlier, the one with multiple people in the room and everyone having something to say. We had already seen two of the solutions available. First was about taking time turns, which could be translated to time division multiple access, and the second was about sharing different pitches, which was about frequency division multiple access. Well, here's another one. Take an ideal case of these people being users of different native languages. Just think about it. What if every set of people in the room are speaking different language? It means that the unintended languages will just act as a noise, and focusing on your particular conversation will not be a big issue. Here, the woman is speaking in Hindi and the man is responding in Hindi. The bearded guy and his partner are speaking in English, whereas the other two are speaking in Mandarin. The advantage is the woman doesn't know Mandarin, and the guy with the beard doesn't know Hindi or Mandarin either, which means that whatever the other people are speaking is pure noise for him, and he can simply concentrate his focus on the English conversation. This is called divided by language. Now let's translate this into the context of telecommunication. Earlier in 2G, we were working with relatively low frequency, and the users were divided by time turns and pitch. I said relatively low because the frequency was higher than 1G, but it was still lower than what was allotted for military purposes. The divided by language solution was also implemented for military personnel, as it granted more security and efficiency. But more on that later. We need to replace the notion of language with code, and once we do so, it becomes code division multiple access for consumers. Wait, what code? What division? What are we talking about? Let's expand on this further. As you already know, the antennas transmit and receive data frames. In terms of code division multiple access, the data frame was divided into two parts: the code portion and the data portion. The code was different for each and every user, and it was exclusive to him. Instead of time frame and frequency, the users were now identified by a unique code. This simplified a lot of things. The code could be one of the two types. Either it could be mutually orthogonal code, which was used for military purposes, or it could be pseudo-random code, which was used by consumer service providers. These codes were used to identify the users, which means that every data frame carrying a particular code belonged to the same user. Now it was up to the base station or the antenna of cellular tower to determine which frequency range to use to transmit this particular frame of data. The base station was not limited or bound by any assigned frequency. It could use whatever it had within its own pool, because the user was not identified by the frequency configured. He was identified by the code it possessed. While doing all of this, we had mentioned earlier as well that the frequency band was enlarged due to less user information or compressed user information within the code and larger frequency. We could transmit more data in each frame. This allowed many forms of data to be introduced into the world of mobile communication. Apart from voice calls, users could also make video calls or video streaming. They could do heavier web browsing compared to 2G. They could share or receive geographic coordinates through map applications, or they could be exchanging endless data for social media applications. And just like how we used to map the users earlier in a particular box, now the user's boundaries had increased. A single user's data could travel from any of the boxes or even more than one boxes at the same time. That's why CDMA was also known as spread spectrum technology, because the user information was spread across the spectrum. It was not limited to a particular configured frequency. The proper 3G adaptation of this technology was known as high frequency WCDMA, where W stood for wideband. This had a lot of advantages. First of all, high frequency meant less noise, because the higher the frequency goes, the lower noises can penetrate. It also meant it was time to say goodbye to jamming, because now the frequency was so high that jamming was not possible. Pseudo-random code improved the notion of security. It was more difficult to track the calls illegitimately unless the carrier itself provided the information. And all of this led to smoother calls, smoother handoffs, and higher quality of service, which fits perfectly with the intents of 3G. This technology was so powerful that it changed the notion of mobile communication, and that's why most of the 3G was built around different protocols of CDMA. These are just different names for different specifications of the same protocol, where WCDMA had the highest frequency band, where CDMA1 had the lowest one. But this doesn't allow us to judge these protocols. The size of the frequency band does not always define the quality of service provided by a carrier or even the data speed you might get under the certain protocol. The thing is, mostly the spectrum size depends on the number of users. So highly populated areas are most likely to have mammoth-sized frequency bands, whereas less populated areas can just work with smaller bands as well, and they can still provide better connectivity. With that said, it's time to summarize 3G. Trivially, it is the third generation of wireless communication. NTT Docomo in Japan was the first to commercially launch it with WCDMA support in 2001. 3G channels were 1.25 MHz wide compared to 200 kHz of 2G. Don't confuse it with the spectrum limit or the frequency band allocated to the base station. They are different things. Channel indicates frequencies allocated to a particular user, whereas the band indicates frequency available to the whole base station. And by the stats, you can say a 3G channels were 6 times or more wider than 2G ones. Mix it with the compressed user information and you will realize how the data frames of 3G could encompass really complicated and large-sized data such as video calls or video streaming. Which brings up the next point: higher data rates, tighter security due to high frequency, and better quality of service, just as we had seen with the WCDMA. Most importantly, this brought a necessary shift in the paradigm of how mobile communication was treated, and the phones were not just calling devices anymore. They were turning into smartphones, the devices that could do a lot more, that could house apps which were as smart or as functional as computer softwares. Users were literally holding small computers in their hands, and users could do a ton of things with it. Text chat, social media, gaming, education apps, everything was now on the tip of your fingers, which is nothing less than amazing. And this was the third generation of 3G of mobile communication. In the next lecture, we will talk about how humanity's greed never stops and something can never stay perfect by looking at the issues of 3G. Till then, happy learning, and I hope you have a great day.